Okay, today we are going to look at how to do graph drawing. I'll go through with you the very detailed, the very slow and detailed process. But once you master it, you should be okay. So plot the data for all the temperatures in the range, okay, 20 degrees Celsius to 50 degrees Celsius on the grid. Okay, do not include the results for 55 degrees Celsius. Okay, so make sure you all read the question first. Okay, so let's take a look at the table. So in this case, we are not going to plot this according to the question. Do not include in the graph. Okay, can. Now, first thing first, before we plot any graph, you first need to ask yourself, okay, which one, what is the y-axis and what is the x-axis? Okay, first question, okay, you need to ask yourself, what is the y-axis? Okay, and what is the x-axis? Okay, so if you look at this table, how do we know which one is the x-axis and which one is the y-axis? Okay, you need to remember this. Okay, the x-axis is usually the independent variable. Okay, this is the independent variable. Then the y-axis is usually the dependent variable. Okay, in the previous some of the earlier lesson, we would have talked about independent and dependent variable before, or you should have learned this in Set 1 and 2. Okay, so this should be a recap to you. Okay, so what is independent variable? Okay, independent variable is the variable to be changed. Okay, is the variable planned to be changed. Planned to be varied during the investigation. So before you start the experiment, before you start the investigation, you already plan that you want to change this variable, okay, during the investigation. So it's the independent variable is the variable planned to be varied, okay, during investigation. Okay, during the investigation. Then dependent variable is the variable that you are measuring or observing during the investigation. So dependent variable is the variable, okay, which is being measured. Sometimes we do measurement, sometimes we just make observation. Okay, if it's a quantitative data, okay, that we are collecting, then we need to do measurement. Okay, if it's a qualitative descriptive data that we are looking out for, then we just make observation. Okay, so I hope you all understand what there are different types. So dependent variable is the variable which is being measured or observed during the investigation. So if you remember this, identifying the x-axis and the y-axis is very simple. Okay, so in this experiment or in this question, the temperature will be the x-axis. Then the time taken to become colorless, okay, will be the y-axis. Okay, so first step, you need to identify which one is the x-axis, which one is the y-axis. Okay, then on a side note, usually based on my observation, usually I say usually I never say 100%. Okay, usually they will put x-axis on the left-hand column. Okay, this is the left-hand column. Usually. Okay, y-axis usually they will put it at the right-hand corner, right-hand column. Okay, but you must understand, sometimes we don't have to give you in this format. Sometimes we can give you in another format. Okay, top and bottom. Okay, I can do this. The question can give you in this manner. Okay, in this format. then usually based on my observation, okay, the x-axis, they put it on the top, okay, then the y-axis is below. Okay, so in the event, if you really cannot remember what is independent variable, dependent variable, the next best scenario for you will be, if you can still remember, Mr. Ang say x-axis usually on the left-hand corner or on the top row, okay, left-hand column or the top row, okay, then at least there's still a chance for you to get it right. Okay, so I emphasize again, this is usually the case. Okay, Mr. Ang, sometime if I want to irritate my student, I may swap this around. Okay, to test whether you remember dependent variable and independent variable or not. Okay, so come back to graph drawing again. So first thing first, you need to ask yourself, what is the y-axis, what is the x-axis? Okay, next. Okay, next, you need to identify the highest value and the lowest value on the x-axis and the y-axis. Okay, so for the highest value is 50, and the lowest value for temperature is 20. Okay, so usually I identify the highest and lower. Then I will get 50, get the highest value minus the lowest value. I get 30. Okay, then likewise, I do the same for y-axis. I also identify the lowest value and the highest value, which is 20.5. Okay, so 20.5 minus 2.5. Okay, give you 18. Okay, so second step, you do this for both the x and y axis. Okay, why? Okay, why? Actually, to tell you why, let's look at the grid that is given to you. The grid is the space with lines for you to draw your graph. Okay, so usually we will plot our the y-axis is the vertical axis. So usually our y-axis we will draw it on it will be the vertical axis, and I will usually draw the y-axis on the leftmost line of the grid area. Okay, then the y-axis. By the way, you'll need to draw this line with the arrowhead using pencil and ruler. Okay, now I don't have ruler, so I draw freehand. Okay, so this should be your x-axis. Okay, so the y-axis is the vertical axis. Usually is the vertical axis, and usually I put it on the leftmost line of the grid area of the grid area. Okay, then for x-axis is the horizontal axis. And usually I will put it, I will draw it on the bottommost line. Okay, I know my English a bit weird. I don't know whether there's this thing called bottommost line, but never mind. Okay, bottommost line of the grid area. So you need to know this. Then I will tell my student, you count the number of squares. You count the number of big squares. Okay, what do I mean by big square? Okay, this is considered one big square. This is one big square. Okay, so I will count. I have 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. Okay, I have 10 big square for the y-axis. Then I also count for the x-axis. Okay, 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12. Okay, now Mr. Ang is writing all this 1, 2, 3, 4 is to help you visualize so that you can see what I'm counting. Okay, in exam you just count already. After you count, you just write. Okay, so for y-axis I have 10 big squares, right? So I come back to here. Okay, so the step number 2, I know 30, then I know I have 10 big squares. Okay, then for the, no, wait, I write wrongly, sorry. Okay, this is 10 big squares should be here. Okay, Y-axis is 10 big squares. Then the x-axis is 12 big square. Okay, 12 big square. 12 big square. Okay, why I count? Because I want to know what is the interval to use. Okay, what is the interval? Okay, what do I mean by interval? Okay, let me remove all this number already. Okay, so that I don't have to copy and paste and rewrite everything again and again and again. Okay, so let's do it. So when I say interval, interval is very simple. So by right, every 10 small square, okay, you need to draw this so-called interval line. Okay, I don't know whether it's called interval line. Let's call it interval line. Okay, both for the y-axis and the x-axis. Okay, y-axis and x-axis. You need to, every 10 small squares, you need to draw this, and you need to tell me what is the value. Okay, what is the value at each interval? Okay, so how do I decide? Okay, come back to how I decide. So for y-axis is very simple. I just get the largest number, the largest value on y-axis that I need to plot on y-axis, and the smallest value that I need to plot for the y-axis. I minus them, I get the value, the range. This is like the range. Okay. Then I get the range divided by the number of big squares that is provided. So I know it is 1.8. Okay. So I know each big square must be 2. Okay. We round off to the nearest whole number. Okay. The round up to the nearest whole number. Okay. Round up. We round up to nearest whole number. Okay, then I know each of my interval must be at least 2. Okay, then I do the same for the other one. 30 divided by 12. This one will be 2.1, 2.5. I think it's 2.5, right? Okay, so for the x-axis, you can leave it at 2.5 or that's not correct. This one should be there. Okay, if I round up to 3, I can round up to 3 to the nearest whole number, or I keep 2.5. Okay, later we will look at the grid again. So come back to this one. Okay, to this one. So I know for my x-axis, each interval, because this is 2, x-axis is 2.5. It can be 2.5 or 3. So I know each of this now is 10 square, so it's 2 big square, so it can be 2.5 times 2 equal 5, or 3 times 2 equal 6. So can be either one of them. Okay, then I know for this one, it will be 2. No, it's 2 times 2. Okay, 4. Okay, so this is what I mean. So this is 1 big square. 1 big square. Okay, 1 big square. This is 1 big square. This is 1 big square. Now, next thing before we can start plotting, you need to ask yourself, should I always start from 0? Okay, let's look at this. Should I always start from 0 and 0 here? Okay, should I always start from 0 and 0? Okay, to make we are running out of time already. So I'm not going to wait for ask people to answer my question. I will just tell you. Okay, you do not need to start from 0. Okay, for biology graph drawing, you do not need to start from 0. Okay, the origin doesn't have to start from 0. Okay, I don't know what you learn from maths and other subjects. Okay, for biology, I'm telling you, you do not need to start from 0 all the time. Okay, because if you start from 0 all the time, your graph may be too small. Okay, so let's come back to, let's look at the table. So for the x-axis, I can actually choose to start from 20. Okay, then for the time taken, because the smallest value is 2.5, it's very close to 0. So for the y-axis, I can still start from 0. Okay, so this is what I mean. So let's look at this one. So y-axis, I can still start from 0, but for x-axis, I will start from 20. Okay. Then if I use whatever just now I have mentioned, I can fill up, I can label the interval now. Okay, I need to remove some of these things. You should have written down anyway. This is being recorded. Okay, so you can go and watch it. Okay, I'm going to remove all these things because all this will be replaced later. Okay, by something else. So you see, 20 to 50. Okay, 20 to 50. For x-axis, right? Do you realize that I cover the entire range? Okay, on the grid area, and my graph will not be too small in terms of the x-axis. Okay, can. Now, so let's look at the other one. So 2.5. So this one, this one will be 5, 10, 15, 20, 25. Okay, so again, I managed to cover from 2.5 to 20, 20.5. Okay, so the value, the interval that I have used allow me to plot all my data point on the y-axis and the x-axis, and I ensure that the data point are well spread out. Okay, so that we get a big enough graph. Okay, the graph must cover at least, so I write here. So the size of the graph, okay, size of graph must occupy, okay, must occupy at least half the space provided. Okay, sometime if we want to be more strict, we may say at least 3/4. Okay, but 3/4 is difficult. Okay, but half is easy to achieve. Okay, if you can, if you can choose a scale. Okay, if you can choose the scale for the y-axis and the scale for the x-axis such that, okay, the graph covers 3/4 of the grid provided. Okay, you are very good. Okay, that would be even better. Okay, but bare minimally, okay, bare minimum, you should aim for at least covering half of the x-axis and y-axis. Okay, and I am very particular about it. Okay, I will count the number of big squares. So in this case, when I say half, okay, your graph must cover at least, so in this case, for this example, for x-axis, your graph must cover at least 6 big squares for the x-axis. Then for y-axis, your graph must cover how many big squares? This is 10. Must cover at least 5 big squares. That means your graph must be bigger than 5 big squares for the y-axis portion. Okay, for the y-axis, and then your graph must cover at least 6 big squares for the x-axis. Okay, and the method that I just went through with you allow you to fulfill this requirement easily. Okay, so I hope you all remember that. Okay, so let's remove this. Now, before I continue, okay, you need to label the x-axis and y-axis clearly. Okay, you need to label the x-axis and y-axis clearly. Yeah. So for the x-axis and y-axis, you need to include a clear label and the unit. Okay, I always tell my students, just copy the heading of the table. Do not change any word. Okay, so in this case, the y-axis is time taken to become colorless / minutes. Okay, this is the unit. Okay, this is the unit. Okay, so I will just write, I will just copy exactly, don't change it. Okay, time taken to become colorless. So I will write here, no space. So I write above, time taken to become colorless. 10 minutes. Spell out, copy the heading exactly the same as the heading. Then for the bottom one is temperature, degrees Celsius. So I'll write here temperature slash degrees Celsius. Okay, can then once you have settled this, then you are ready to start your plotting. Okay, plotting, please use crosses to indicate the data point. Okay, so let's do the first one. Okay, 2 at 20 is 18. Okay, at 20 is 18. Y-axis. Hey, by the way, I forget to mention something. The y-axis is 0.5, so it's to 1 decimal place. That's why when I label my y-axis, I also follow the same, okay? So this one should be 0.0. Okay? 0.0. If you write 0, I can penalize. So follow for the number of decimal place, follow the table also. Okay? Then for the x-axis, do you realize there's no decimal place behind? So it's 20, 25, 30. So I don't put 20.0 because 20.0 is correct. If I go and write 20 is correct. 20.0, you may be marked wrong. Okay? So follow the table. Okay, just follow the table. For the number of decimal places. Okay. So 2018. Okay, so 18. So this one is 15. This is 17.5. This is 18. Okay, this is the one. So I will draw a cross. I will represent the data point using a cross. 18 is not this lah. What am I thinking? Oh yeah, I'm correct. This is 18. Okay, then you plot 25, 10.5. Okay, 25, 10.5. 25 is 10.5. So 10.5 is this one. Okay, then the next one is 34. 34. Okay, cross use cross use crosses to indicate the data point. Okay, to mark out the data point. Do not use dots. Okay, unless the question asks you to use dots. Okay, then 35, 35, then 2.5. Okay, 2.5 will be here. Okay, then 40 is 5.5. Then 45 is 12. And 50 is 20.5. Okay, 50 is 20.5, so it should be here. So do you realize that my data points are spread out? Okay, are well spread out. Okay, and I cover almost the entire grid area. Okay, do you realize that I cover the entire grid area for the x-axis? Then for the y-axis, only this portion and this portion not covered. Okay, but here to here will be at least half of the y-axis. Do you realize that my plotting, okay, cover at least half of the y-axis? Okay, if you follow the method that I do just now, okay, take the highest value minus the lowest value, calculate the range, then you calculate the number of big squares, you get the range divided by big squares, you can determine what is the interval for each big square. Okay, so you do for x and y axis, and if you do that, you can easily fulfill it. Okay, you can easily fulfill the requirement that your graph is at least half the space provided. Okay, half the size of the grid area in terms of the x-axis and the y-axis. Okay, next. Okay, drawing best fit. Okay, most of the graph that you are asked to draw, you are supposed to draw either a best fit line or best fit curve. Okay, very rare they will ask you to just join the points using straight line. Okay, very rare. Okay, I never say never. Okay, so in this case, you look at the data point, you know this is obviously a curve. Okay, so this is how I will draw. Okay, please bring your curve rule or French curve to draw the curve. Okay, Mr. Ang don't have. Okay, even if I have, I cannot draw it. I cannot use it on the screen properly. So I will just use freehand. Okay, So I will start from here and I will try to draw as smoothly as possible. Okay. So this is a very good graph because you can get a very smooth curve. Okay. So best fit curve later I will talk about it. So this is how you draw the best fit line. Okay. Now, one thing I want to emphasize, do not protrude, do not draw anything beyond the last 2 points. Okay. Anything beyond the last 2 points, okay, they are considered as extrapolation. The 2 extreme points, they are considered as extrapolation. Extrapolation is not allowed. You will be, marks will be deducted. Okay, extrapolation is not allowed. Okay, in biology. So do not extend your line beyond the last, the 2 extreme data points. Okay, on the left and the right. Okay, so extrapolation is not allowed. Okay, is not allowed. Can I? Now then, since we still have some time, let's talk about best fit, best fit line, best fit curve. This is what I mean. Imagine I have a data point that looks like this. Okay, usually you should have at least 5. Now, okay, if you were to draw a best fit line doesn't have to pass through all the data points. Okay, a best fit line will be at equal distance, okay, to all the data points, or is as close as possible to all the data points. Okay, so this is what I mean. So for this example here, when I draw a best fit line, okay, do you realize that it doesn't, oops, okay. Let me draw the dotted line so that I don't do extrapolation. Okay, so I also teaching you how do you avoid extrapolation. So I will redraw my best fit line again. Do you realize that by best fit line, this is my best fit line, by the way, this is the best fit line that I'll draw. Do you realize that my best fit line doesn't pass through any of the data point? Okay, so I want to emphasize again, best fit line doesn't have to pass through any of the data point. But if you go and look at it, all the points I have 2 data points above the best fit line, this one and this one. Okay, two data point above, and then 3 data point below. Okay, for best fit line and best fit curve, you need to aim for equal number of data point above and below the best fit line. Okay, but if you have 5 data point, you cannot have equal number. The best is 2, 3. Okay, either 2 on top, 2 above, 3 below, or 3 data points above, 2 data points below. Okay, then do you realize that the distance between the data point, okay, this distance, okay, this distance here, and all this distance, if I were to add them up together, okay, if I add this three distance, this distance, okay, this 3 distance from the graph, and this 2 distance, okay, together they should be about the same. Okay, if you are able to achieve, a very good, a perfect best fit graph, a best fit line or best fit curve, these 3 distances, okay, addition of these 3 distances from the data point to the best fit line, okay, addition of 3 distances from the data point to the best fit line, and then addition of the distances from the 2 data point above, okay, they should be equal. Okay, so if you are able to achieve this, your best fit line or best fit curve is perfect. Okay, but we are human. Okay, we are not robot. So very unlikely we are able to do that. But you still need to try to draw your best fit line such that at least to the teachers, marking your graph, okay, we can see that effort is put in to show that you know what is the best fit line. Okay, can then only left 1 minute. I need to end soon. So let's summarize. Let's summarize what are some of the things that you need to take note. So later, never mind. Let me summarize. So I tell my student remember this word slap. Okay, slap. Slap someone. I'm not asking you to slap people. Okay, size, scale. S can stand for size and scale. A stands for axis. P stands for the plotting. L stands for the line. Okay, so size and scale, you must choose. This is the scale of the x-axis and the y-axis. Okay, the size, the scale that you choose for x-axis and y-axis must allow your graph to be at least, okay, to be at least half the space provided, half the space provided. Okay, that means the grid the grid area. Okay, line must be best fit line, smooth. Fit line, smooth. You can take a seat first. Yeah. Is your picture here ready? Okay, then axis, label, plus units. Then plotting, all correct. Okay, sounds logical. Okay, if not, I will send a SLS package on graph drawing. Please go and complete it. I cannot remember whether I have sent you all that before, but never mind, I'll send it one more time for your revision. Then I will also send the answers to this worksheet, okay, on Google Classroom. Please go and look through it and before next Tuesday. Okay, we need to end first, end already. The next period teacher is here. Okay, and thank you.